And this can be fixed if teachers teach us to have good code style, just like they teach us to use correct algorithms, use accurate algorithms everywhere. So they can teach us a code style to help us improve in our job. The other one is modeling. We just think things in programming or arrays or maybe functions, but in fact, to be a good software engineer, you need to see everything as object and model it with an object or a structure. Also, this can be fixed with good teaching. People say that we overestimate importance of performance. So we need everything to be very efficient when it's not needed. Sometimes it's good because when data is a lot, we can write efficient codes that works, but others can't. Also, we are good ones to choose fast enough, easy to implement codes. For example, when constraint is low, we choose to implement fluid partial algorithm instead of BFS because it's easier to implement. One of the most important bugs of competitive programmers is arrogance. Some nights we want to be best everywhere. We want to win competitions. This is not just related to job. We can destroy our friend community, our family, because we are arrogant. We are born to win everything, be the best. This can make managers feel insecurity. Hey, that person says that I know nothing. We really think that the 13 years old manager doesn't know anything to teach us. We are the best. And but it is not just related to competitive programming. Every person with achievement winning some competitions like Olympic or etc. Has this arrogance maybe. We maybe think that others know nothing. This can be fixed if we teach students to be just like normal people. Don't be arrogant. And conclusion is we can be potentially good in our job. The quote saying competitive programmers are bad software engineers has reason more in soft skills. But we think that they say our code is ugly or other things. And finally, Norvik, the man was talking in the first movie, said that I regret causing confusion here, and the data was incorrect, and we are not bad in our job. And thank you, everyone. Any questions?
Would you say that, according to your code, would you say that competitive programming has gone a bit too far related to what should be the regular programming?
It's right, but people say that we are not doing competitive programming to become a good software engineer, for example, okay? People say that we are doing it just for fun. And making them close together is something maybe impossible, because in software engineering you have many soft skills to make the team, but competitive programming is mostly individual competition, so it's somehow impossible. But yeah, we can make them closer if we be good teachers. You're welcome.
Yeah, I hope so.
So I don't think that next two speakers need too much fun introductions. In the Bear, Nicky Garrison, their tools, the tools that they develop are all around the World Finals. So I think that I will just let them do their thing. Welcome.
I think I'll try without the mic. If I'm not loud enough, let me know. Okay. So thank you for letting us talk for a minute. Nikki and I are part of the systems team that runs the World Finals, and we work at many regional contests to run the contests as well. Today we're going to talk about the contest API, which is one of the key things that we use to run a large contest. We're going to talk about the limitations of the current contest API and some work we've done to open it up to team clients. And we'll do a demo at the end. So first, what is the contest API? There's a group of us that have been working on contest control systems and running contests for many years now. And we finally got together and used 4 years ago an API that we've been working on for many years before that. It's a REST and JSON-based API, and it basically allows you to talk to a contest control system and say what teams are competing, how many submissions are there in the contest, what is the logo for the University of Team 57. And it basically gives you access to all of the standard data that clients would want from a contest control system. So it does talk a little bit about roles. We have super users in the system. We have teams. We have public scoreboards that are out here that can show more data than the scoreboards on the contest floor. But it doesn't say a whole lot about certain roles like teams, and there's very little support for modifying things in the contest. For instance, when you'll see John probably pause the start of the contest, that's in the API. An admin can do that, but there's not much else. Okay. So, why did we create the contest API? It's really about interoperability. We used to have a lot of problems every year. We have a new version of PC squared. We're going to switch to use DOM Judge or Caddis this year. And okay, the interfaces are different. You parse this data a little bit differently than I expected, and now, it's a pain trying to set up for the finals. Now that we have the contest API, those have, basically disappeared. We have a whole set of different tools, and they work with PC squared, they work with Caddis, they work with DOM Judge. It's relatively easy for us to go to a contest and, you want a presentation or use the resolver against a different contest control system. It generally just works. What does the contest API not have? It really doesn't have a team role. You can have a team, client, something running on a team machine that would look at the contest API. It could get lots of information about the contest, but there's no way to submit, and there's no way to get clarifications. So why is that important to have in the specification? Well, we'll go through a number of things that you kind of can't do easily today. The first is different team clients. So if I'm a team and I have a local contest at my university, and then I go to a regional contest and they use a different contest control system, and then I come to the finals and we're using a third contest control system, each one of those is going to have a different interface, a different way to submit. Maybe one uses a command line, another one uses a web interface, and as a team, you need to adapt to that. It could be kind of annoying to remember how each one works differently. There's no way to automate tests. So it would be great for finals if we could say, here's last year's finals. We're going to pump it into your contest control system. You're going to tell me what results you got, who you think won, And we'll use that to verify that the contest control system is generally working, or validate that another contest control system satisfies the contest API. You can't do that easily today. At the finals, we run 2 contest control systems for the last 10 years, let's say. And we run one to actually run the contest, and then we have another one that verifies the results. So this year it's Dom Judge running the contest and Caddis verifying the results. Each CCS basically has extra code to run in shadow mode, because there's no way to write a generic tool that would support that. And if we want to switch over, if we actually said, hey, we want a hot swap, maybe we found a problem in one of the CCSs, or maybe we just want to handle the fact that something may fail, we might find a bug at the last minute. You would need to give completely different instructions to the teams on how they access it. They're going to see a different scoreboard, and we need to install both clients on the teams. Got some other, maybe minor issues. Let's say one of the CCSs builds a great client. They have integration in, let's go for IntelliJ, and a submit button right in it. Well, we switch contest control systems next year. You can't use that anymore. We have to rebuild it. We can't have an ICPC team client. So hey, we're going to have one client that we use at all ICPC events, and it's the same. Teams don't have to learn anything new each year or each contest, and it just works. Can't build something like that. And likewise, configuration. So on the team machine, which CCS are we using? Okay, we got to install this thing. How do we do auto login? How do we do different things? It's per CCS. Then it may surprise you that for this year's finals, we were looking at some potentially very complex scenarios in how we ran the finals. What if we end up with people in different regions joining their own finals? We had a group of 7 teams over here and 25 teams over here. Okay, now what happens if the internet goes down at one of those sites? What's fair? How do you maybe block updates to the scoreboard at one site where the judges and everything is sitting to be fair to the teams at another site that don't have internet access at the moment. Implementing that could be horribly complex depending on what we decide the right rules are. And if we switch CCSs the next year, we'd have to write it all over again. So, 3 of us in particular, Mart, Nikki, and I, but also the rest of the Clicks team, a few who have wandered in here, have been talking about this and talking about extensions to the contest API, and what would it mean to allow a team role on the contest API. So we have a proposal. It basically gives a team ability to post submissions and clarifications, just one additional REST method, and for an admin to be able to post a submission or clarification, but say it's from this team and it was at this time, which is for cases where you might cache or pass through a submission. And as with any API, as a team, you wouldn't know whether you're talking directly to Dom Judge or whether there's something in the middle that is doing something special. So on the server side, Dom Judge has already implemented support for this, and the CDS, the contest data server that we use to feed the presentations and control some things here, has a proxy mode. So you can submit to it as a team, and it'll just pass it on to Dom Judge. On the client side, we decided, to prove the CLI, to prove that the API is working, we should build a little client. I wanted to learn Go, so the other 2 guys helped me learn Go a little bit. We built a little command line tool that works for this. And it's also, a useful CLI. Depending on how things evolve, maybe that's, a common CLI that we can share. So we have the simple CLI. It can submit to a contest control system. But there are more, interesting scenarios that we could decide to support once this is in the API. So first, of course, is simple proxying. You could have something that kind of shields the CCS for whatever reason. Maybe you need to do some network, moving of the flow. You could have a caching proxy. So at my site, I submit, but if the internet goes down, it caches it. When the internet comes back up, it sends it through. And you can then decide, at other sites, what you do with the scoreboard or other pieces of the API. You could have seamless shadowing. So when a team submits, either you just have a proxy that splits and sends it to two CCSs, or you have one that just listens to a CCS and says, oh, you submitted to Dome Judge, I'll go and pass it to Caddis. And you don't need to do those things directly in the CCS. And then some more, did I talk about all of those? You could do crazy things at this point with proxies where, we run the CCS at Dome Judge here, Caddis in another location, PC Squared at another site. They all judge locally, but then they send the results to another site for verification. So, now one time. You can go bigger if you want.
So let me start by just running the command with the help. For example, I can list some basic things like what problems are in this contest. You can see there are, I think, 11 problems. I can let's show some clarifications. Well, as you can see, it still requires some work. Big clarifications are not readily readable. But of course, the interesting thing is to submit. So I have here an Untitled Java file. I want to submit it, so I say contest, Untitled Java. It tells me a lot of stuff. It tells me the contest. I pre-configured our demo web of Dome Judge to connect to, and this contest, the Android 2018, which we are running there. It auto detects that it's problem A, and that it's Java, because we call it Untitled Java. And it detects the entry point which is needed. So I can submit it. I press yes. It tells me it's submitted. 14 hours into the contest. This is a very long contest, which I now can view with submissions. And as you can see here, this bottom one, it's the submission. It's queued because we're not actually judging on this machine. But it's there. I can also show you the web interface. Very secure passwords always. Oh, and here it is. This is the one I just submitted. It's a basic demo, but it all goes through the API. If Caddis at some point implements this API, the same tool would work there.
So that's it. We just wanted to show you where we're at with the contest API, and hopefully we can finish specking this and maybe run next year's finals on it.
Yeah.
Thank you. Any questions?
I'm sketching through the API description on the site, and there's a lot of things called ICPC ID. So the first question, is it possible to use your API for the non-ICPC contests?
To the API, we've tried to keep generic and leave a little bit of flexibility for different styles of contests.
Why is an ICPC in the API?
No, there's no ICPC in the...
Well, there are some fields called ICPC ID, right?
Yeah.
They're all optional.
Yeah, they're
they should all be optional.
Okay.
You can just leave them empty. I think
And if you
nothing
want
really
different kinds of, that's for an ID, so we know what it came out of the ICPC CMS database.
Yeah.
It's optional. You could add another field if you needed a different kind of reference.
So how, how generic do you plan to make this API? I mean, there are lots of rules and lots of combinations of parameters. For example, what about byte point scoring?
Yeah. That's one thing that
iOS.
Yeah,
iOS,
there
that's one
are
thing.
lots of sub-kinds of this scoring.
Yeah. So we've tried to put a little bit of flexibility in the API. Frederick, sitting at the back, just added a different like scoring result. So that part is optional. But until we have other contests that try to use it and say, oh, the API is a little bit too strict, or hey, it worked, we don't know.
Yeah, so if people need stuff in the API, I guess the whole API thing is backed by a
Okay.
GitHub thing, create an issue.
Pull
explain
requests
which
are
one.
welcome, yeah.
Or an issue, I mean,
Yeah.
then we know, we don't know who uses the API outside of us, right? So if we know who uses it, we can extend it.
Yeah, and likewise, like the resolver, it kind of assumes ICPC rules and looks for that scoring. It wouldn't be terribly hard to look for other scoring
And,
algorithms, but
Is does API includes, I mean, even in principle, shall it include in the future like scoring table or whatever?
it has a scoreboard, but it leaves it up to the CCS to decide like what the ranking is. how
So
to make the
it's
scoreboard.
kind of it's unspecified data, yeah? So it's like just raw text or whatever.
There's a separate CCS spec that says what the correct scoring is for
Okay,
world
and,
finals and.
What about like some testing suite or whatever? If, for example, I want to implement this, do you have some like semi-official test suite to check implementation?
I mean, we have like a validator and a few things like that, but without the team API, you can't have something that like submits and makes sure that a judgment gets back, and so it's missing a large chunk that we could verify, I think, down. But like making sure that the contest you return looks reasonable. we
Yeah,
have
but by
utilities for
hand,
that.
or is it already auto test?
Sorry?
Is it already like other automated tests already?
No.
So there is a JSON schema at least.
Yeah, of course I can look, like, just view it with my eyes. But
No, so there is a
There's a-
JSON schema, and you could use that automatically. I think DOMDutch actually does that every time we push changes. It verifies it against the schema to see if it's still correct. So you could use that. I don't know
And
where it
we've
is,
got
but
a
it's somewhere.
utility that will check, like, you've got a team that says it's from an organization. Does the organization exist? Are there problems for submissions for problems that don't exist? That kind of thing.
Probably I missed the link, but is your command line tool open source?
Oh yes,
Yes.
we didn't put the link in yet.
Yeah.
It is open source. We are currently discussing whether we can put it on some ICPC related URL, and otherwise we'll put it somewhere else.
It's MIT.
It is open source.
Okay, could you share a link now?
We can share
Yeah.
a link. It will move at some point, but I think it's.
I have the tab open. But
You have a tab open.
you have to fun time finding where it browser.
Oh, good luck. So we split the tool up in two parts.
somewhere on GitHub.
Oh, no problem. So we split the tool up in two parts. We have the actual tool, it's the CLI tool, and we have a library written in Go also, that's the backend implementation. So you could use that without the front-end tool. For example, if you want to integrate it in JetBrains, Visual Studio Code, whatever. Yes, that's it.
Okay, thank you very much.
Yes.
Well, amazingly, we're on time. So, our next speaker is Ragnar Groot Gorkamp. And I don't know if.
Yeah, that's it. Sorry.
Since that you.
Sorry,
Okay.
I have a bit of problem. I just learned that my laptop does not support screen mirroring.
Okay, we
And
can.
it's live demo only.
Yeah, we have.
So
We have
there's one more tab after me,
another
right?
one here. Or?
There's one more tab after me, right?
Yeah, that's right.
Here.
Yeah.
Can you go now? That would
Do you
help
want
me,
to
actually.
switch?
No, I just need to fix my laptop a little bit.
Okay. So, do you mind?
I'm okay.
Yeah.
Yeah.
Okay.
Okay. Sure. Thanks.
two others have little switch of the last two talks.
No, I don't think so. Let me not use it like last presentation. I will turn it off. Can you please turn it off? I don't want to use it. This one. Oh, I don't want to use it. Ah, okay.
Perfect.
Okay, I'm back again. The name of what? Let and not make the students grow. I started teaching when I was studying for Iran National Olympiad of Informatics. From the beginning of my study in Olympiad, my dream was to become a coding teacher, and I still like it. Being with students and training with them and watching their growth and joining to some company and their achievement, seeing their achievement is very interesting for me. After these years of teaching, I'm here to share some experience. This one is one of the most important experience I can share, because the students around us are not normal high school students. They want to discover things. They want to be their own, not just some student that learn something and go solve some problems. They want to discover algorithms. They want to discover things and go further. There are two different styles of teaching in Iran. We call them American style and Chinese style. I don't know if they are appropriate name in other parts of the world, but we call American style the style that we teach everything and then give some homework. And the Chinese style is some mix of teaching and solving problems at the same time. For example, you give some problems and the students come with some ideas, and then you teach some points. The main trick in this method of teaching is after the students solve some problems, you need to fill the holes by your teaching after that. One of the techniques can be used in Chinese style of teaching is using of model problems. For each category of problems, we can define or find a model problem, and we give them to students. They will try to find a solution. Some of them will find and will invent the algorithm they want to teach. Some of them will fail. But when we tell the right algorithm to them, their brain grow. Okay. So, for example, consider this problem for teaching segment tree. Consider we are given array A of size 2 to the power n. Create a half-size array using bitwise OR. Or accept. So there is a distance between solving the problem and implementation. You can ask them to mention, yes, I solved it, but not enough time to implement it. Contest is another important part. Regular exams with absolving and asking students to participate in code forces contests, culture contests, and many other jobs, and reviewing the contest after it's finished. For example, after your exam is finished, ask them to solve one or two more problems and discuss with them about the solutions, about the editorial. The fact is, a contest makes a lot of pressure on a student's brain, and this rise the growth in short amount of data, in short amount of time. Another ideas about preparing contests for exams for the students is give problems that they don't know its algorithm. So they start fighting, but they can't do anything. Sometimes they invent something new. I have experienced this. But if they don't do so, after the contest, they are ready to hear the algorithm. They are ready to see what was the answer. Also, irregular contests, maybe as a fun, are nice. For example, a contest with 10 problems, all easy. They are just coding, and it makes some fun. It's something irregular, and maybe help them grow and making some fun. The last point that Nikolai Kalinin helped me was to make community. Instead of teaching students, make their community. They'll make each other. They'll help each other grow. Help students to create community. For example, if you teach at several universities or several high school or several circles, connect them together. They will compete with each other and they will grow. The community makes people motivated. For example, I remember that when I was high schooler, a big community was around me, and I was really motivated to become better, gain more rating in code forces, solve more problems in the contest. But in university, there is something like no community around us. Opposite to the other parts of world, that they are more interested in computer programming in university. We are more interested in computer programming in high schools. And thank you. Any questions?
Well, I'm gonna have to look at the TV screen to get the presentation. So, ICPC tools in Google, you'll find it. So this is software for working on problems in the problem package format, and this is typically the way problems are developed when you import them to Caddis or Domjudge or other contest systems. So a typical structure is you have a problem statement with a tag, sample data with input and answer files, secret data with input and answer files, and then accepted submissions and time limit or also runtime error submissions.
Can you increase the font size?
Yes. And then we have input validators and output validators that are used to check whether the input adheres to the. Wait, you can see there and there. I can't see it. Anyway, okay. So what I'm going to do is just I'm going to develop a program from scratch and show you how you can use BPC tools to do this. So the command for BPC tools is BT. So let's make a new problem. Oh my God. Oh. Sorry, I just messed up my. make a new problem. And the problem we're going to do is you get the list of n integers. Is this font large enough? Maybe not. Okay, so the problem is summation. We're just going to give you n integers, you have to sum them. So the author is me, and it's default validation. So the answer is just an integer. There's nothing special going on like an interactive problem. Okay, so now we can do 3, and okay, now I have to scroll. We have like a new problem called summation. Now I go to my text editor. The first thing we do is we edit the problem statement. So let's write something. Given n integers, find their sum. And then the input consists of one line of a single integer n between 0 and let's define some. Let's make it 10 to the 5 integers between 0 and 10 to the 4. So this is the number of integers. And then one line containing n integers. So that's a1, an, the integers to sum. And then we put some bounds. So here we have 0 less than ai less than this max a we defined. Okay, and then the output is just output the sum. Okay, now we have a problem statement. So what we can now do, we can do bt PDF. It says it didn't find any test cases because we didn't add those yet. And now we have a problem with PDF. So now here you can just see it's like given n integers. It's just what we wrote in it late. I missed the phrase, but okay. So we have a statement. Now let's add some sum. Let's first add some sample cases. So we go to this directory data sample 1.in. So maybe we have 4 integers, 1, 2, 3, and 4. And then we write an answer. Maybe we write 10. Well, not maybe, that's a sum. And then we make another test case. Let's not make another test case. Okay. Let's write a solution. So we go to submissions, accepted. We always call, in our juries, we always call them by your own name. This is, okay. So we do, so we read the number of integers, and then we do, we have a list of integers, that's like input dot split, and then we make ints of that, and we do print some L. I think this should work. So now what we can do, let me close the problem statement. We can do 3. So we see that we have an accepted submission, and we have here 1.in and 1.end. So we can do, we can run. So now it's compiling the input validators, the output validators. We're still to write them. It will probably complain actually. It will definitely complain. This building is a bit slow. So it says the input validator is not good because we didn't edit that yet. But it says that it's running a submission, accepted Ragnar, and it's accepted. So it got the right answer from the sample test case. Let's write an input validator. So we go to input validators, and then the CPP file. Wait, this is wrong. Okay. Oh, this is a bit large. So what we do, we read an integer n between 0. Let's define these again. This is the same as in the statement. And then we read a new line. And then what we do, we read the integers. There's a special command for this. So we just read the integers a. There's n of them between 0 and max a. And there are some special options to read unique integers, but we don't need it here. So now we have an input validator. And we can do validate. So it's good. And then let's also write an output validator. This is very long, but in the end, all that this is it's just reading an answer between 0 and 1 billion, which is fine. This sum is always in this range. Okay, that's nice. Let's do one more thing. So what this is doing, it's checking whether our input actually matches the range of what we told it in the input validator. So here it says, for example, the value of n at this line in the input validator was never equal to the lower bound of 0, because we only had one test case with value 4. So now we know, but actually we're never going to make a test case with n is 0. So let's just increase that lower bound to 1. Okay, so that fixes the first of these errors, and then was never equal to the upper bound of 100,000. So now let's make a test case where this is 100,000. How am I doing on time? Halfway, or?
No, we're good.
Okay, well, so let's make a generator. So what we can do is we have this generators file. So here what we can write generators that generate test cases. So let's write gen.py. So the arguments to this generator are like n, and the rest will be random. So import sys, import random. So we say n is int argv1, random.seed int sys2, and then random.rand int. So let's do max a is in Python is like this, I think. So this is just like n random integers, and then we print those L integers. Or like. Now we're going to call this generator. So in this data, in the secret directory, what we do is we make a random case, or let's first make a small case. So we do gen.py. First we put n, so let's make a case with n is 1 for this lower bound. And then we put a seed, and the seed will be randomly generated. So there's a random seed, but it's fixed. So if you re-render multiple times, the seed is fixed because the seed depends on the hash of this part of the line. So if it changes 1 to a 2, the test case will be different. But if I do this, these two test cases will be the same, and you will get an error. So let's make two. We have a small test case, and then let's make a large test case. So we do 100,000. And now we can do generate. You see a warning that we didn't specify a solution to use, because currently our generator only generates inputs, but we also want to generate answers. So currently just picks one of the accepted solutions to generate the answers. Now we got some complaints. Oh, our small test case didn't pass the...
You probably printed an array, Python list instead of...
No, I don't think so. I put a star here.
Yeah.
Oh, I didn't print n.
Yeah.
You're right. Thanks. Okay, so now we have two more test cases, and we can list them, and we can watch them. So one very small test case and one larger test case, and this continues down here. Now we can run this constraints again. Let's see what it says. There's lots of templates in this input validator, sadly, and it makes it very slow to compile. So the value of answer was never equal to the lower bound of 0, because our answer is currently always positive. Like our smallest answer is 10, this small test case we added. So let's also do something about that, and it's also never equal to the maximum value. Let's first do something about that. So what we can do is we can reuse a generator or write multiple generator scripts with lots of manual options, but actually we can do something more fun. So if we go to this generators directory, we can reuse our input validator, because this input validator contains a structure of the test case. So what we do, we symlink this input validator. And now we go to this generators.yaml file. So let's say we make a maximum test case. What we do is we call this input validator. We have to pass a generate flag. So what this does, it just tells the input validator, instead of validating the input, it actually will generate a test case. And we pass the seed to heavily deterministic. And then we can say n, we want it equal to its maximum value, and a, we also want it equal to its maximum value. And what we do here, we can do this because if we look at this input validator, here we put this n, and these a as variable names. So here we can reuse those flags, and we can just say, make it its maximum value. So if we now do generate, nope, I'm in the wrong directory. Okay, so now we have a new test case, and you can see that it put everything to this, and now if we do constraints again, you see that another warning is gone. So that's nice. Okay, one more fun thing. Let's edit our solution. So Ragnar.py. Okay. Okay, so let's introduce a bug here. And this bug is stupid, but doesn't matter for the moment. So let's do assert that the sum is not, the sum modulo 101 is not equal to 5. So this will fail roughly 1 in 100 times. It's just like an example for a bug that occurs rarely. Like, probably you have some actual bug in your code and just doing this for demonstration. So this should fail roughly 1 in 100 times. So let's run it. It's accepted. Now let's do some fun. We do fuzz, and it's gonna fuzz. And because we have the seed, it can replace the seed with other random numbers. And ideally, after roughly 100 attempts, we expect it 50, it finds an
Maybe you
case.
should put a slightly lower number.
Yeah, maybe I should.
Yeah.
This is not too interesting. Yeah.
By 11.
Yeah.
No, even lower.
Yeah. Okay.
Yeah, what yeah.
This went better in practice, bro. This should work, right? Yeah. Oh, I know the problem. So in our generators.yml, we only put a max case, but this is always divisible by 10, something like this. I think this is the problem. Like, none of these actually depend on the seed much. So we just do a random case. So we just like don't specify that it's a maximum value, just random. Another thing we can do, by the way, is like something like binary. We just say it's 0 or 1, and then it's random. Don't specify this. Oops, not good.
Well,
That's an internal error. Maybe again.
That's right, it's an assertion error.
Sorry?
It's an assertion error in the Python code.
Yeah, this is in my this is in my software, not
That's
in
what you wanted, no?
No. If things are working nicely,
You
it's
found.
what is
this.
no. This is maybe I just
This is
disabled parallelism.
the assert you wrote in your solution.
Yeah. Yeah, it's no.
Maybe it's not just not code. I mean, exception was not correctly code, but it had.
Okay, well, you get the idea. Normally this works, but
Yeah.
I should fix it. So basically, what it's going to do is going to add here. It's basically going to copy this line at some point, but then instead of the seed, it just puts some random number or some fixed number, and then you know that you've just broken a submission with this particular seed, and now you can just add this. I haven't used this much in practice, but I have occasionally found like bugs in jury submissions for the N-work. I will probably run it also for our current DPC contest and N-work this year. Yeah, so there's a lot of things you can do with the software. Actually, let me know. Yeah, so like we can run, and then we can run more verbose, and then you see what it does in all the test cases. I think that's it. I can show more, but these are all the most interesting features here. Yeah, so any questions? Yeah.
Do you support the cross-validation of the solutions? For example, we have a number of correct solutions, and they all pass. All of them pass. We have some number of wrong answers.
Yeah, of course. Like I can make like
wrong and things like that.
like a
This is automated.
submissions, wrong answer. So I can do that, apply, just print 1 or whatever. If I now do this, it will say that this accepted and this wrong answer, and this green because it's expected to be wrong answer.
Okay.
But now if I do, if I copy this to accept it and run, like it's complaining that it's giving the wrong answer.
So, this is somewhere on GitHub, yeah?
This is?
I mean, this is some open source.
Yes,
tool,
yes,
yeah?
of course.
So, my question is actually, how is your code structure in regards to dependency on particular problem format? Yeah, you see the question. Yeah, there are obviously two
It's like
parts here.
not
Yeah.
written with any kind of other program format in mind.
Yeah, but you see, basically everyone in at least in this row has written just very similar to. I have this, he has this, he has this.
Yes.
And obviously there are some like small interesting ideas or pieces which you would like to pick, but we have very different problem formats. And
Yes.
it would be like interesting to
I think
separate those.
at the core, it should just work. Like you still have a concept of accepted and wrong answer submissions
Yeah,
and
of
test
course.
data. But I think making it compatible will be a lot
Do
more.
you have automated time limit,
Yeah,
time
that's
limit interval?
Yeah,
we-
time limit I also have like.
For example, you have set of time limit solutions, set of accepted solutions,
Yeah, yeah.
Yeah, yeah.
and to recommend the time limit, for example, as average.
Sorry.
For example, you have set of solutions or that are accepted. Set of solutions there shall time limit.
Yeah.
You are running and have fastest solution time limit and slower accepted, and just use approximation like
Right.
squared.
Yeah, you want a
squared
geometric
multiply
mean
to-
between two something.
Yeah.
So this I currently do not support. I know Program Tools does this by native.
It can be useful to with automatic
Yes.
time limit.
The thing is, regarding time limits, that in development we just fix them to be the right value for a continuous integration server, because you can also use this as continuous integration for
Yeah,
every time
this
somebody pushes.
actually becomes more useful like when you run the system for multiple years. So you pick an old problem, you want to
Right.
quickly reuse
Yeah.
it, and it's,
If you upgraded your
So the thing is, this is very much for jury development. It's not so much for like Don't Judge or Caddis like hosting a repository for us, right? It's just
yeah, but
developing.
yeah, you know, a jury.
The simple example, we just upgraded all of our invokers, so we need to update time limits to make sure what the participants will solve the same problems
Yes,
as it
yes.
was on the competition 5 years ago.
And also we have like 2,000 problems.
Yeah, so I know our problem format has support for this, it's just that I didn't implement this yet because we ourselves don't need this.
In fact,
But I'm very happy to support this, yes.
In fact, this task about movement is not so late. Once I tried to use Petrozavod scan submission and mirror it OTG scan, both PC was in, but some tail. We had tail solution that original contest that's very faster on new PC than accepted solution on original contests. So,
Yeah. In the end, we always fine-tune our time limits for actual contests, so yeah.
At real contest difference was
Yeah.
relatively high. It's same testing.
Do you understand correctly that you do not use test sleep for validation?
I do not use.
Test sleep, this is, you didn't hear about test sleep yet.
No, I wrote my own.
Okay.
So the thing is, I was using check test data before.
Okay, so are you familiar with Polygon?
No, I tried it once, but
Yeah, it's very similar in
yeah.
functionality.
So the thing is, in our like BMC and NWork contest, we use this program format, and I once made a
Yeah, but I mean
Yeah.
the functionality of problem
So-
preparation
yeah.
system itself. It's like the same
Of course.
checks, same like even very similar syntax in some parts.
Yeah.
So it's,
So the thing is, I use check test data, and then I wrote my own input validation library, and I really like this library now because I can also use it to generate test cases, and I'm not aware of
of
any
course,
other.
and so
Yeah.
it's kind of usual. You follow the usual trajectory of similar systems.
Of course,
and
yeah.
so I would like to
Like
compare.
I
and
think there
discuss
should
it.
be a list of these systems because I'm really only aware of Polygon and this format, and I'm really only aware of program tools and BBC tools to edit these formats. I don't know any other tool in the world. There exist many, and this does not surprise me, but I just don't know that. And I was frustrated with program tools, so that's why I wrote my own. Yeah. Yeah. Thank you.
And then we're done for today. Thank you to all of you for coming. Let's hope that it's not another 2 years before we can meet again in the next CLI. and enjoy the rest of the World Finals Thursday. Thank you very much for coming.
Thanks.